So we've talked about some qualitative measures of concentration. So we've talked about concentrated versus dilute, and a concentrated solution is just where there's a lot of solute for a given amount of solvent, and dilute is the opposite. We talked about supersaturated, unsaturated, and saturated as well, but we need a more quantitative measure. And so by quantitative, we need a number, so something that we can compare and do calculations with. And in chemistry, we almost always work with molar concentration. And molar concentration, or just conc for short, we often just call molarity, and this is our chemistry concentration. And we define molarity as follows. It is just the number of moles of solute divided by the volume of the solution in liters. So for example, if we dissolved, I don't know, say 0.45 moles of sodium chloride in some water, and the total volume was, say, 3,000 milliliters, we could use this to calculate the molarity. So let me go ahead and push the board up. There we go. Okay, so how do we find the molarity? Well, first of all, there is a shortcut to writing the molarity of something. And what we normally do is we put the something in square brackets, and this essentially means the molar concentration of what's inside. All right, so then we just divide the number of moles of solute, so that is 0.45 moles of sodium chloride. It's good practice to probably go ahead and say what it is you've got moles of, because when we have reactions, we'll have two different things or three different things, so we need to keep track more easily. But we need it in liters, and we've got it in milliliters, so there's a couple of ways to do this. And so one is to go ahead and remember that there are 1,000 milliliters exactly in a liter, and so that gives you 3 liters. Or you can do it another way. So let me push this up some more. You can go ahead and you can say, well, milli means 10 to the minus 3. So milliliter means 10 to the minus 3 of a liter. And that gives you actually the same answer. And it kind of depends on how you want to remember it. Quite frankly, I was taught this way before I was taught this. So I kind of always reach for 1,000 mils in a liter, although really milli is 10 to the minus 3 is probably better. Another way to do it, quite frankly, that's easier, is just to take that decimal point, and because you're essentially dividing by 1,000, right, you're just moving it back 3 times. And so if you want to go milliliters to liters, you just move the decimal 3 to the left. If you want to go liters to milliliters, you just move the decimal 3 to the right. And if you just remember, right, that a milliliter is about 20 drops of a substance. And when you go to the grocery store and you buy pop, you buy it in a 2-liter bottle. You should remember that liters are bigger than milliliters, because you buy pop by the 2-liter, but a drop of water is about a 20th of a milliliter. So just kind of have a rough feeling in your head for the size of these two things. All right, so now we are ready to go ahead and fill out the rest of this calculation. So we have 3 liters. Okay, now if we go ahead and we do that division, so we got 0.45 divided by 3. So significant figures, this has 2, this has 4. So since we're dividing, we can only go by the fewer. So that is 2. So it is 0.15 moles per liter of sodium chloride. And that's one way to write it. Another way we can write it is we can write 0.15 moles liters to the minus 1 sodium chloride, because remember, right, if you've got something to the minus 1, that's just 1 over that something. And it's sometimes written that way, although not very often in general chemistry. Another way to do it is to go ahead and use capital M. And capital M is our abbreviation, and capital M is our abbreviation in chemistry that means moles per liter. So we use it so often, we find that it's inconvenient to write it out in full every time, so we just use that abbreviation. And by the way, I didn't pick these amounts out of thin air, actually. This is actually the physiological concentration of sodium chloride. So if you have physiological saline, it has exactly this concentration. If it's higher or lower, and you give someone an intravenous of saline, you'll probably kill them, or at least make them sick. But if it's got this concentration, they should be fine. And one of the interesting things is actually that this concentration here, this physiological saline concentration, is exactly the same, or almost exactly the same concentration as salt in the oceans. And it's interesting to think that all life on Earth started in the oceans, and it's interesting that still to this day, even though we don't live in the ocean, our bodily fluids have the same concentration of seawater. Isn't that cool?